second of two videos on project management. This one describes network planning models used to plan, control, and monitor projects. In particular, we will be discussing how to implement the critical path method and how to use it to learn about projects. Since a project is made up of a sequence of activities, it can form a network. You can actually draw a form of a flowchart. That chart is called a network diagram or a precedence diagram. The term precedence diagram refers to the fact that some activities precede each other, and we look at immediate predecessors. That is, the tasks are done in a sequence. CPM, or the critical path method, is used to determine the critical paths in project networks. The critical path is the path that takes the longest time through the network of activities. It is also the path in which all of the activities have zero slack. We'll define what slack means as we move through this presentation. So quickly, to recap, the critical path is the longest path in the network. It has all zero slack activities. But the key element here is that any delay in these tasks will delay the project. That's why it's important for us to understand what the critical path is. We do what-if analyses on the project to determine how to make the project take less time. So for example, if something changes in your environment and you need to get this project done faster, you may shorten the tasks on the critical path or ask if you can, or work on how could you do that. You may try to do certain things in parallel so that they get done at the same time rather than in a sequence, or you may sequence them differently to allow for the critical path to be shortened. Doesn't happen often, but you do need to know how to do it. So, what do we need in order for us to do this critical path methodology? A project has to have three things. It has to have well-defined jobs or tasks whose completion marks the end of the project. Okay. Independent jobs or tasks, that is, they must stand alone by themselves. You have to be able to put your hands around it. There's a beginning, a middle, and an end to each task. And the tasks must follow a sequence. Otherwise, you can't use CPM because it's designed to look at things in a sequence. So there's two types of critical path methods out there. There's one that uses a single time estimate. The CPM folks like to call this having certainty. It's not really certainty. What this means is there's no probability attached to each activity time. With CPM with 3 activity estimates, it's used when you do have a probability for each of the activity times, and you create a single time based upon that probability information. So for example, when I was a project manager, I'd ask each person with responsibility for an activity to let me know the optimistic or the best case time, the least likely or the worst case time, and the most likely time for each activity. Then I'd come up with a basic average for each activity that took into consideration that things could go very, very well, or they could go terribly wrong, or they could just be just right. So you basically don't use most likely, you use some a surrogate that takes into consideration that activities could be different. So when we do the single time, we identify the activity, that goes without saying. You look at the sequence of the activities and you construct a network, and then you determine the critical path. Almost all of the project and activity timing information can be obtained from the critical path. So let's look at an example. We'll just do a CPM with a single time estimate for this one, and we'll look at the other one later. Okay, so we have a consulting project that has 7 activities labeled A through G, and each one has a time. Okay, right here, each in weeks. It could be in days. And then each one has an immediate predecessor. You see that A has no immediate predecessor. That tells you it's the first activity in the network. So let's draw our network. first thing you do is look at A. So here we have A. The number in parentheses is the time it takes, and it has no immediate predecessors. B comes after A, and it takes 1 week. C comes after B, it takes 1 week. D comes after C, and so does E. Okay, they both come after C. And D takes 2 weeks, and E takes 5 weeks. F has as its immediate predecessor D and E. So you cannot start F before both D and E are done. Okay? And then the last activity is G. It takes 1 week. And you can see that you can probably determine what the completion time is once we get there. Okay, so we have to calculate some other numbers in order to finish this out. We do what's called a forward pass, where we calculate the early start, early finish, and the completion time. A backward pass is when we calculate the late start, the late finish. Okay, so let's do that. So a forward pass, our early start for the beginning activity, in our case A, is 0. The early finish for A, in our case A, is the early start, i.e. 0, plus the time that that activity takes. So the designation T and with A in parentheses denotes the duration of an activity. Okay? And the early start of A is the larger of the early finishes of all predecessors of an activity A. The completion time is the larger of the early finishes of all ending activities. So our completion time in this case is going to be the early finish of G. A backward pass allows us to calculate the late finish and the late start. We start with the late finish. So the late finish of an activity is the smaller of the late starts of the successors of that activity. And a late start is the late finish minus the duration of that activity. So let's see how that works. But first, let's talk about slack times, because we have to figure out what the slack times are in order for us to determine what the critical path is, right? So we have two types of slack times: total slack, which is a gross measure and the one that most people use, and it is the late start of the activity minus the early start of the activity minus the early finish of that activity, or basically the late finish of that activity minus the early finish of that activity. We also have something called free slack time, which is basically a way to look at what's sort of left over. Most people don't use free slack time, but it can give you some additional information about the critical path in terms of um, what activities have free slack in them. So that's our slack time. We will be using total slack time. Okay, so let's determine our forward pass. Forward pass is pretty quick. All right, so the early start of A, since it's the beginning activity, is 0. We add the duration to it, so the early finish is 2. The early start of B is 2, which is the same as the early finish of A. We add 1 to it, so the early finish is 3. The early start of C is 3, which is the same as the early finish of B, and the early finish of C is 4. The early start of E is the same as the early finish of C. We add 5 to it, which means that our early finish is 9. Our early start of D is the same as the early finish of C, which is 4. We add 2 to it, and that gives us the early finish of 6. Now for F, we have to figure out which one of these we're going to use. And remember, we use the larger of the two. So therefore, the early start of F is the same as the early finish of E. Why? because E ends last, and so therefore you cannot start F until E is done. That's another good way of looking at it. We add 5 to it, and so therefore our early finish of F is 14. G cannot start before F is done, so the early start is 14. You add 1, and the early finish is 15. So let's look at our late starts. Our late start of G, we take the early start, the late finish of G is the same as the early finish of G. We subtract 1 from it, and we get our late start, which is 14. For F, the late finish of F is the same as the late start of G. We subtract 5, and so therefore the late start of F is 9. For E, the late finish of E is the same as the late start of F, and we subtract 5, so the late start is 4. For D, the late finish of D is the same as the late start of F, which is 9. We subtract 2, and so the late start is 7. For C, we have to decide which one of these late finishes and late starts we're going to use. So we will use the late start of 4 from E as the late finish of C, subtract 1, and the late start is 3. Why? Because we use the smaller of the late starts of the successors. And the successors of C are E and D, and the smaller one is 4. And then moving on to the late finish of B, that is the same as the late start of C. We subtract 1, and we have the late start of 2. And then for our final, or our first activity, the late finish of A is the same as the late start of B. We subtract 2, and our late start is 0. Okay, so we've done our forward pass, and we've done our backward pass. So now what do we have? We have to figure out our slack. You can eyeball this and see that none of the activities, all of these are 0. Okay, so all of these are on the critical path. The only one that has slack is D, and that is because the late start minus the early start and the late finish minus the early finish is 3 weeks. It's not 0. And so our critical path is A, B, C, E, F, and G, and the duration of this activity is 15 weeks. So that's how we do CPM. If you have any questions, feel free to send me an email or discuss it in another forum. I'll probably set up a forum for this, but that's how we do it. Now you can proceed and do the exercise that's posted on Canvas.